Hello, friends. Last lecture in our organic series. We're going to talk about the reactions that organic compounds can go through. And we're talking about the 7 most simplest reactions. There's a billion different chemical reactions happening in your body right now that are all organic reactions, but they're much more complex than we need to study at this level. We just need to get an understanding of the basics. Organic compounds exist, but what type of chemical reactions do they take part in? We've done single replacements, double replacements, oxidation and reduction reactions, synthesis and decomposition so far, but there are a few other reactions that organic compounds like to do. And these compounds are far from the complete list, the 7. We're just going to hit the surface of them. Organic reactions. The first one is combustion. It's a type of oxidation, technically. It's when a hydrocarbon, alkane, alkene, or alkyne, is burned in the presence of oxygen. O2 is a reactant to produce water and CO2. So you know you've got a combustion when you've got 3 things going on. A hydrocarbon on the left, reactant side, oxygen on the reactant side, and CO2 and H2O as your 2 products. That's how you know you've got yourself a combustion reaction. Let's see what the first alkane, alkene, alkyne, oxygen gas plus carbon dioxide, and water are always produced in combustion reactions. Now, technically, other hydrocarbons do burn. Organic compounds can burn. It's not just alkanes, alkenes, alkynes, but again, we're talking about the simplest situations. The second series of reactions is a substitution reactions. This happens when you swap a hydrogen for something else, usually a halogen. So you have a hydrocarbon, a halogen, and you get a halocarbon, and in this case, a hydrochloric acid. So we've got alkane plus a halogen making a halocarbon and acid in this case, because we know that's an acid because it's got a hydrogen out front. HCl is stomach acid, so it's pretty common stuff. If you were to look at this in a different way, same reaction, C3H8, so that's C3H8 plus the chlorine. And the chlorine actually came in there and replaced this hydrogen. So now that hydrogen is a chlorine. And that hydrogen went to the other chlorine, and now we have HCl. So a substitution is what has occurred. One hydrogen is substituted for a different element, usually a halogen. Addition. This is when atoms or groups are added to the multiple or double, triple bond of an unsaturated hydrocarbon to become a saturated halocarbon or hydrocarbon. So in this case, we have C2H4 plus halogen, chlorine, making C2H4Cl2. So we've actually just added 2 things to the molecule. Alkane or alkyne, pardon me, plus a halogen makes a halocarbon. The way this actually works is these chlorines come in and kind of attach to the carbons. And they're both added on the same side of the molecule. But I guess after the fact, they can rotate around and be on different sides. But you have a double bond, add the chlorine to it, and you've basically broken the double bond, made a single, and each chlorine is now attached to a carbon. That's a addition reaction. Not a substitution, but an addition. We've added more on to the molecule. Esterification is when we make an ester. The way you get that is you put an alcohol and an organic acid together, and you get an ester and water. This is called a condensation polymerization technically, but it's esterification because you're making an ester. Organic acid, that's that COOH group. Alcohol, that's that OH group. Ester, there's a COO with another chain on the other side. So we got 2 chains with the COO and bridging in the middle. And of course, water is water. Visually, graphically, these are usually equilibrium reactions. They're not one direction all the time unless you remove the product as it's being produced. So we have our organic acid plus our alcohol becoming the ester, the bridge, and we've got our good old water made right there. So remember, we got these 2 branches hanging off our esters. Saponification is an interesting reaction. This is the only place we really study it. It's making soap. It's when we have, well, an ester plus a base making alcohol and soap. A soap is a molecule that has two ends. So it's got a hydrophilic, likes water, end, and it's also hydrophobic, hates water. Okay, soap is so good at getting oil off your hands because the hydrophobic part of it attaches onto the oil. And then it washes away when you put your hands under the running water because the hydrophilic part of it carries the dirt and the molecule away with the water as it washes down the drain. A triglyceride is a fancy way of saying fat. It's a type of fat, trigs. NaOH, that's a base. You get glycerol, so you basically cut the molecule here, and you get this glycerol. And sodium palmitate, which is this long chain with a sodium attached on it. Okay, so sodium palmitate. So this part of the molecule likes H2O, and this part of the molecule likes oil and grease. So for that reason, it's got a hydrophilic and a hydrophobic end, and therefore it will wash away when you put your hands underwater. This reaction is very complicated. What you just need to know is that saponification is making soap. Fermentation reaction. This is a very complex reaction, but it's when we produce alcohol and CO2 from sugar. And this requires an enzyme to do the job. So this requires brewing of some sort. So you can't just like mix sugar and get alcohol out of it. You have to have some biological process, which is the enzyme, do the job. So we got to make sure that we've got our enzyme listed here. This is usually done by yeast, not the same type of yeast that's in your bread, but a similar type of yeast. So that yeast eats the sugar, produces carbon dioxide and alcohol. A different type of yeast is used to rise bread because otherwise it would be alcoholic every time you make bread. Now the last reaction we're going to cover is polymerization. I did mention it, condensation polymerization, a couple minutes ago, but this is the formation of large molecules. Okay, it's a really, really important process for practically everything we have today in our modern culture. Polymerization is done either by an addition or condensation. Addition polymerization is basically when you take molecules and you link them together to make long chains that just continue on for a long time. They continue on. They just keep on going. That's a direct addition polymerization. It's very straightforward. Boom, you take the molecules, you slap them together, they just keep on going on, making a very long chain. Condensation polymerization is when you take two molecules, most specifically organic acid and an alcohol, and you link them together. So the OH and the H come across, we lose a water molecule, and now we have this part of the molecule is still here, and this part of the molecule is now there. So we have actually linked two chains with an ester. That's called esterification. It's how they originally made this stuff called polyester, which is a nice plastic-like fabric that's used in so many different things in our modern culture and society. So at this point, you should understand that there are 7 organic reactions: combustion, substitution, addition, fermentation, esterification, polymerization. Ooh, and I'm forgetting one. Look back at your notes. Recognize and categorize them. There's a couple practice page packets, and there's one quiz on the organic reactions and a prep associated with it. So thanks for watching your homework this unit. Only one left to go after this.